Hello, I welcome you all to this another interesting screencast. We are going to be solving this engineering mechanics problem, and it reads: the dragster starts from rest and has an acceleration described by the graph. Construct the velocity time graph for the time intervals 0 to time for time 0 to t prime, where t prime is the time for the car to come to rest. Okay, so solution. So when do you think the car is going to come to rest? When its velocity is equal to what? 0, right? To have rested. Great. Okay. So we also need to find time t prime, right? But here I want to also construct not only the vt, but I also want to construct the st, position time graph. Okay. So this is the acceleration here. So from 0 to 5 seconds, the acceleration is constant in this 20 meters per second squared. Every second, the velocity increases by 20 meters per second. There we have negative 10 from 5 to t prime, negative 10 meters per second. Okay, the dragster is accelerating the negative direction or decelerating, right? Okay, so what we need now here to find the velocity time graph. So let's pick an interval. So we have t from 0 to 5. Okay, all right. So we know that instantaneous acceleration is equal to dv over dt. Okay, writing this, we have dv is equal to a dt. Okay, and our from 0 to 5, our a is equal to 20 meters per second squared. So we'll have to replace this where there. Therefore, our dv is going to be equal to 20 dt, and we need to integrate this. But what integrating constants are we going to use? We know that at t equal to 0, our v naught is going to be equal to 0, right? Why? Because the dragster starts from what? From rest. Okay, so therefore we'll have 0 there to v, and then time 0 to t. If we integrate this, we are going to have v is equal to a 20t, which is a linear equation. So let me write this here. From 0 t, from 0 to 5, we have v equal to 20t. Okay, 20t. Sorry. Okay, and then from 5 to t prime, our a is equal to negative 10 meters per second squared, and t equal to 5 will give us what will be our v. Our v naught is going to be equal to 20t, which is equal to 20 by 5 equal to 100, right? So our v naught is going to be 100 at this point. Okay, so integrating, we'll start from 100 to v dv is equal to, we're using the same equation, right? just replacing. The time is from 5 to t. What is our a here is negative 10, right? dt. Integrating this, we're going to have a v minus 100 is equal to minus t minus 10t minus 10t minus 10t plus 15, right? And therefore our v is going to be equal to minus 10t plus 150. All right, so from 5 from 5 to t prime, our velocity is equal to minus 10t minus 10t plus minus 10t plus 150. Okay, so I said you also find the st graph, the position time graph. All right, can I wrap this? Of course. We know that the instantaneous velocity is equal to ds over dt. So let's look at the first interval. And writing this, we have ds is going to be equal to v dt. In the interval t from 0 to 5, where t is equal to 0, our displacement s naught is also going to be equal to 0. And our ds, we are integrating it from 0 to s is equal to, in this interval, our v is 20t, right? 20t dt integrating from 0 to t. If we do the integration here, we're going to have s is going to be equal to 20t squared over 2, which is equal to 10t squared. Then from the interval 5 to t prime, we have the constants at t is equal to 5, s naught is going to be equal to 10t squared, which is equal to 10 by 5 squared, which is going to be equal to 25 by 10. So this is a 250. Integrating, of course, our s naught starts from 250 because we are starting from here. 250 to s ds is going to be equal to, our v is this one here, it's a minus 10 t plus 150 dt. So we are integrating from time is equal to 5 to t. So if we integrate this, it will give us s minus 250 is equal to minus 10 t squared over 2 plus 150t. So this is going to be equal to a minus 5, a minus 5, a minus 5 t squared plus 150t minus, so it goes to minus minus, that becomes a 10 by 5 squared over 2 and minus 150 by 5, right? So this becomes equal to that's 10 by 5 squared divided by 2 minus 150 by 5 plus 250. Okay, so this therefore becomes equal to S is equal to minus 5 squared plus 150t minus 375. Let's check this one out. At t is equal to 5. So we must get the same solution for the displacement, position equal to 10t. So we have S is equal to 10t squared, and then we have S is equal to minus 5t squared plus 150t minus 375. So S of 5 is going to be equal to 10 by 25, which is equal to 250. Then this one, S of 5 is going to be equal to minus 5 by 5 squared plus 150 by 5 minus 375. So this is going to be equal to minus 5 by 5 squared plus 150 by 5 minus 375. So it gives us 250. So it means our equation at 5 is supposed to give the same result. This one here and this one is supposed to give the same result because this is the boundary that we picked. There is supposed to be a continuity here. So it means our equation is fine. So let's indicate these equations here. S in this case is going to be 10t in this interval 0 to 5, and then there is going to be equal to, can I wrap this? It's going to be equal to S is equal to minus 5t squared plus 150 t minus 375. And when you look at these equations, if you differentiate this, okay, you get V and you get exactly 20t, right? You see? Okay, and if you differentiate this, you get 20 constant, and the same goes with this. If you differentiate S with respect to t, if you differentiate this one, you're going to get this, right? Let's try it. ds over dt is going to be equal to minus 5 by 2t plus 150. This is a 10t plus 150, you've seen? So it means our equations in are okay. Alright, just wanted to show you that. So once we are sure that our equations are fine, then we can go ahead to start doing what? The plotting. Let's plot. Alright. Okay, so here we have B, which is in meters per second, then we have time in seconds. Here we have S in meters, then we have time in seconds. All right, so 0, we have this point here which is 5, then we have this point here which is T prime. Okay, we have 5, then we have this point which we are calling T prime. All right, so how are we supposed to find T prime? They've told us to say our T prime is the time for the car to come to rest, and the car will only come to rest when our velocity is equal to what? 0. Okay, so our V is going to be equal to, and is in the interval 5 to T prime, is in this interval. All right, so I'm going to use this equation there, minus 10 T plus 115. So what will be the value of T when velocity is equal to 0? Our T is going to be equal to 15. So therefore our T prime is equal to 15. Hence this point is 15. And this point is 15, right? Yes. Our T prime is 15. Okay. So let's start the plotting right now. So V in the interval 0 to, this V in the interval 0 to 5 is just a linear function, so it will be something like that. It will be something like that. Okay. It's something like that. And this value here, we are saying V of t at 5, this value is going to be equal to 100, right? This is V meters per second. And then from this point onwards, we have this equation where we're being told minus t squared plus 150. We equate it to 0, velocity is equal to 0, it will hit this point, right? So from here, this will bend over to somewhere there like so. Okay, so it will hit 18, 15 here. Okay, so this equation is V is equal to 20t, and this one is V is equal to minus, it has a negative gradient, plus 150. So we are done with the first one. And then this other one here, the first one is quadratic. So we have a behavior like so, something like this. We have something like this. This point here, this point is 5, 5, s of 5 in there. We have 25, 25 by 10. This becomes a 250, right? So in the second interval from 5 to t prime, we found it as 15. This one here is a quadratic, but it opens the other way around. So it's going to be something like this. Okay, something like that. Okay, this point where the slope is 0. Okay, for this quadratic. This point, if we are to find it, s of 15 is going to be equal to minus 5 times 15 squared plus 150 by 15 minus 375. So if we have to work out this, minus 5 by 15 squared plus 150 by 15 minus 375, this gives us a 750. So we have this point is 750. Right. So this equation is s is equal to 10 t squared, and this one here is equal to s is equal to minus 5 t squared plus 150 t 150 t 150 t minus 375. All right, I guess we are done. We are done. This is about it, really. We are done. We've added one part, which is the position time graph, which was not here, to just spice up the question. I hope the video was helpful. Continue liking and subscribing. Bye bye, and see you in my next task.